This is our third video, and in this video we'll do a couple examples about systems of linear equations and inequalities. Okay, in this example, Paul bought a shirt and a watch. The total sum of the prices before sales tax was $140. There was no sales tax on the shirt and an 8% sales tax on the watch. The total Paul paid, including the sales tax, was $147.20. What was the price in dollars of the shirt? So we're looking to generate two equations because we have two unknowns. We have the shirt and the watch. We do not know the price of either one. So, but what we do know that the price of the shirt plus the price of the watch without sales tax is $140. But with tax, the price of the shirt plus the price of the watch plus 0.08 of the watch is $147.20. So here we could easily subtract the first equation from the second equation. Okay, I'm going to rewrite the second equation the way I should have written the second equation. I could have written it this way, but I wanted you to see how I got there. That this second equation is made up of the price of the watch plus the sales tax on it. So now I wish to subtract this second equation, so I can multiply by -1, and that will give me minus s minus w, that's 1w, this is 1s, equal to minus 140. Now these two cancel out, and this would leave 0.08w is equal to 7.20, and divide both sides by 0.08. Now, if I had to save myself using a calculator, I just moved the decimal 2 places for both the numerator and denominator. That would give me 720/8. So this is 90. So that means the watch costs 90. So the watch costs $90. But we know that the shirt plus the watch costs $140. So the shirt plus the watch, which is 90, must equal to $140. Well, subtracting $90 from both sides gives us the shirt costs $50, right? And that's what they asked for. What was the price of the shirt? Okay, let's look at another example. In this example, we're going to be using inequalities, but we're also going to be looking to create two equations. And we see two equations in our answers. So let's read the question. Each day, Millie jogs at 8 miles per hour and rides a bike at 50 miles per hour. So that's the rate that she's jogging at and the rate that she's biking. Her goal is to jog and ride at least 12 miles in less than 1 hour. If Millie jogged J miles, okay, so Millie jogged J miles and rides her bike B miles, which of the following systems of inequalities represents Millie's goals? Well, she jogs J miles and then she bikes B miles. So we are creating a distance inequality. Well, what does she want from this distance? She wants she wants the distance to be at least 12 miles. So that means 12 or more miles, right? So the amount of miles jogged plus the amount of miles biked must be greater than 12. All right, so that means that choice B, we can get rid of And choice C we can get rid of because it doesn't match what we know should be the inequality, that j plus b is greater than or equal to 12. Okay, so now we want to deal with time. So she wants to do everything in less than 1 hour. But first we have to see, first we know that distance is equal to rate times time. So to get time by itself, we divide both sides by rate. So time is equal to distance over rate. So time jogging, is the distance, which is j miles, divided by her rate, which is 8 miles per hour. So 8 miles per hour. And time biking is b miles, that's the distance she bikes, divided by her rate, which is 12 miles per hour. Okay, and if we cancel out the units, we see that this becomes 1 over an hour in our denominator, but when we flip it over, it becomes j over 8 hours. Okay, so we are not, we know for sure this is time. All right, so she wants to spend less than 1 hour. So putting together the time that she spent jogging plus the time she spent biking, that must be less than 1 hour. Well, these two, the distance inequality and the time inequality, matches answer A. Okay, so that's it for now.